this video, I will cover the two activities left from the last tutorial 4, I think. Anyway, activity 3, which of the following are mathematical statements? So before we do the question, you should know what is a mathematical statement. I actually thought about it and I can't find a precise definition, and I don't want you to memorize anything. Basically, the idea is that a mathematical statement is a statement that can either be true or false. So if you think about it, in MAT102, we usually ask you, is the following statement true or false? Prove it if you think it's true. If it's false, you give me a counterexample. So those are mathematical statements. If you have something that's given to you and you can decide, the statement can not be true or false because you need more information or something, then it's not a mathematical statement. So let's look at this example. The first one, x squared is greater than or equal to 0. Well, if you just look at this, it looks like a mathematical statement because you would say, oh, this is true. But it's not a mathematical statement because we don't know what your x is. Okay, so it's missing the information about x. We don't know what your x is, so you cannot say x squared is greater than or equal to 0. We don't know if it's true. Let's say my x is a dog, then can you say dog squared is greater than or equal to 0? So you don't know anything about that. You don't know if it's true or false. It's not a mathematical statement. So this is not. Number 2, x plus 1 equals to 0. Well, same as number 1. It has no information about x. So I don't know if it's true or false. Okay, we don't know what your x is. We don't know. Well, it looks like it might be a real number. It might be a natural number or something. Well, if it's a real number, then it might be true. Actually, yeah, it might be true if it's -1, but if it's not -1, it's false. So again, we don't know if it's true or false. You cannot decide that, so it's not a mathematical statement. Number 3, x minus 1 has one solution. Well, this makes no sense at all. Not makes no sense. I mean, this is missing a lot of information as well. First of all, you don't know what's x again. Okay, just like 1 and 2. Also, this is just an expression. An expression has no solution. You need to have an equation or something to have a solution. So this is not a mathematical statement either. Number 4, for all real x is greater than or equal to 0. Well, in this case, you'll see that for all real x, which means x is a real number, and it's saying that x is greater than or equal to 0. Clearly, this is false. Okay, so you can decide if it's true or false. So this is our mathematical statement. I don't like this yellow. Okay. So this is our answer. It's a mathematical statement. You know what your x is. You can decide if it's true or false. Clearly, it's false. Number 5, x minus 1 equals to 0 has one solution. Well, it looks like it's true because you're thinking, oh, x is a real number, but they didn't say that x is a real number. Okay, so you don't know any information about x. You cannot decide if the statement is true or false, so it's not a mathematical statement for the same reason as 1, 2, and 3. Activity 4, write the following statements in logical symbols or English as indicated. So the first part, they ask you to write it in English and discuss the difference between the two. Okay, so the first one, if you write it in English, it's for all x, let's say for all natural x, for all natural x, there exists y in integer, or there exists integer y such that x plus y equals to 0. Okay, that's the first one. The second one is there exists, I don't know if you guys can hear my dog, but that was my dog and my cat are fighting with each other. They don't get along. There exists y in integer such that for all natural x, we have x plus y equals to 0. Okay? This part is easy. The hard part is discuss the difference between the two. A common mistake of students is that they think 1 and 2, okay, they are the same. They think they are the same, but they are different. And I will tell you why. For the first one, it's saying that if you pick any natural x, okay, you can always find a y for that specific x, such that x plus y equals to 0. Which means that you find a y for each of the specific x. So if you pick x equals to 1, you find a y with respect to 1. If you let x equal to 2, you find a y with respect to 2. So you can have infinitely many y. Okay, that's the first one. The second one is saying that there exists one such y. Okay, so you pick one fixed y in integer such that no matter what your x is, as long as it's a natural number, you always have x plus y equal to 0. So for the first statement, it's saying that you can have infinitely many y. Each y is corresponding to the x you pick. The second statement is saying that you pick one such y that works for all natural numbers. So that's a huge difference, okay? It's a huge difference. They are not the same. Alright, now let's look at the part 2 of this activity. They want you to write the following statements using mathematical symbols. The first one, there is no greatest integer. Okay, so 1, there is no greatest integer. Since we have a no here, it's kind of problematic because well, if you look at those quantifiers, you never actually wrote there does not exist or something, okay? But this means that if you pick for, let's write it in another way. So for any integer, you can always find a larger. Actually, you can always find another integer that's larger. Okay? If you think in this way, it makes our life easier. So for all integer, for all x in real number, you can always find another integer. So we need to define another integer. There exists m in, wait, why did I write a real number? It's integer, okay, z. There exists m in z such that, okay, so we want your m be greater than m, so such that m is greater than x. Alright, number 2, any real number can be written as sum of two real numbers. Okay, any real number is the same as for all real number. So for all real number, let's pick a variable x in real number. It can be written as sum of two real numbers, so we need to pick another two different variables. So there exists a, b in real number such that x equals to a plus b. Okay? Let me see if there is anything else I need to do. Extra practices. Nah, you guys should be able to finish this. Yep. Anyway, do those questions. It's good practice, I guess. And that's the end. Did I not do anything else? Okay, those were for quiz 2, and it's long past quiz 2, so I'm not gonna do them. Anyway, that's the end of the video. Good luck on your test.